So before I start, I just wanted to tell you what is this context model talks about. Context model, what is context? The word context itself says something as a system representation. So we do represent the context model as a system. Similarly, when I say in an interaction model, clear? When I say an interaction model, so interaction model could be represented by using two situations. That is by using a use case, and also we have a sequence diagram. That is interaction model. Similarly, when you say about a structural model do represents a class model. When I say class model, once again I repeat, context model represents whole as a system. Interaction model consists of two features, that is use case model and the sequence diagrams, or use case diagram and sequence diagram. When I say structural model, clear? When I say structural model consists of a class diagram. When I say class diagram consists of class to class relationship, that is called an association. Along with that, the class will have its own attributes and the operations, you know it. And there are some advancements in the case of a class diagram, that is by using an aggregation model, right? Association model as such. Coming to the concept, last class we have discussed behavioral model. Behavioral model has got two classifications. Is it or not? So again, for describing the behavior model, we use a different case. So we ended the class till the model driven engineering. We have to go to this session. So before I go to this session, you need to understand these concepts clearly. Then only we can understand what is, first you should have a basics of what is a sequence diagram, what is a use case diagram, what is a context model, what is a class diagram, how do you represent a class diagram. And one more thing, in the case of behavior model, we have seen a state. I'll start from there itself, right? Today, what is the state diagram? So state diagram, interaction diagram, and class diagram. These are the three major categories that we have studied in object-oriented modeling. So in the case of object-oriented modeling, so we have studied, there are three classifications, but in depth, we have studied only the class concepts. We have not studied what is state diagram or the interaction diagram, right? In fact, the state diagram and interaction diagram both represents the behavioral aspects of an object. That is, state means the state of an object can change from idle state to some other state, right? For example, we have a telephone. When it is idle, it is into a state called idle. When you pick up a phone, it is a ring, that is dial tone mode. As such, we have the concepts. So let me go to the, once again, this context model fast. So what does this context model represents? Before I go to the behavioral model, so we are at the last point. So context model do represents diagrammatically by using a system. Context, it represents the different context of the situations. Okay. So this is a context model, right? Next model was an interaction model. So interaction model do represents a use case diagram and the use case diagram and the, so this is a use case, interaction of the use case with respect to the actors. That's coming back to the use case diagram. Then we have sequence diagram. Clear? You have a sequence diagram to represent. Then when you have a structured model, the structure model uses a purely the class diagram. Class diagram. Clear? So here is a class diagram. Class diagram with the association, the relationship between these different classes. This I have mentioned. See, when I say class, again the attributes operations could be represented. These are all the different situations wherein how does the structural model behaves, right? Structural model purely represents the concepts of class diagram. Coming to the system modeling, that is the concepts of event model. So what is this generalization? See, generalizations are all the enhancement to the class diagram, nothing else. These are all the aggregations, and generalizations are all the enhancement to the class diagram. This all comes in structural model itself, right? So keeping into the consideration generalizations and the aggregations, all the aggregate models, these are all the concepts represents the class diagram. In turn, they represents the structural model. Aggregation is also one of the part. This is just an enhancement, I would say. So it is same as if like some advancement to the class diagram. So we're enhancing the features of the class diagram. Coming to the concept of behavioral model has two classifications: data model and event model. When I say data model, again the data model are being represented by using a simple activity model. So this is one of the concepts. Carefully you need to identify what all the activities. These are all the activities, the oval shape that has been represented, these are all called the activities or the operations. Okay, so this is simple diagram of an activity model of insulin pumps. That is how does the insulin pump works. So by using activity diagram, previously maybe you have represented the same concept with respect to the other diagram. Clear? Next, even the sequence diagrams are being used to same to represent the activities. See, both diagrams represents the same, in fact. So this is one of the process. How does the actor is involved with respect to this order, budget, database, and the supplier, right? So there are two actors acting on these different orders. Okay. So this was the last class. We ended. We have ended the session at this diagram. What is state diagram of a micro oven? So we had two diagrams over here. See, first you understand the states, then only you could be able to represent how does the diagram flow. Okay. So first, for a micro oven, what are all the states? It is a waiting state. What is waiting state? The oven is waiting for input. The display shows the current time. Half power, the oven power is set to 300 watt, display shows half power. These are all the different states, wherein same as if like what is idle state, what is next state, so what is the end state. So that is being represented with the source at the target. So initiation of the state starts from here, that it is waiting for someone's response to move up to the full power or a half power state. So overall, what you could see in the case of data model or the event model, there are three concepts. One is a activity model. Activity model, that is how do you represent the activities in between the different types of operations. And also we have a one of the diagram to represent the sequence of diagram. See, the budget, it is being validated only when we have something, the instructions from validation, and it is get updated, right? And the active state, which is the active state, see till here, this is active state and this is active state. Till here it is inactive. Till here it is you have a dotted lines that is being connected on this bar. Till here the budget operations is inactive. So once we have a validation, that is the processing of validation here, it gets active. So this is what you need to understand. And also we have a concepts of the state diagram in the case of behavioral model. Okay, so that is a behavioral model is being represented by using a event and the state. The name itself states the event model and the state. How do you represent the event? Events are being represented by the sequence diagram either or by the activity models. Remember, event models are being represented either by using activity model or the sequence model or a sequence diagram, whereas the state model event and the state models are purely based on the state diagrams, for which you need to understand the, if at all the example is micro oven, you need to understand what are the states of a micro oven: waiting, half power, full power. So hope all of you can go through the various state diagrams that is being given. See the states and the stimuli for the micro oven. So one more concept of B. This is a second diagram for which we have a diagram. This one, this is a diagram. So before you start the state diagram, you should have a knowledge of these stimulus, that is what all the states, that is half power. So based on that, see the operations have been represented over here, that is operations of a micro oven, right? So next, coming to the model driven engineering, represented as MD, is an approach of software development. So rather than the program or the principles output of the development process. So let me go with the major concept here. What is model driven engineering consist of? So what are pros? So here the model driven engineering, so it is an early stage of development. Before you start a development, it is an early stage. So it has got major significances on the development. So in the model driven engineering, we have two types of model, that is computationally independent. It is only a theoretical part. You have to remember what are the different types of models in model driven engineering. So you have to theoretically write it: platform independent model, platform specific model, all those things. So I hope we can switch over to the concept of design and implementation, because we need to cover what are patterns. This is an important point with respect to examination or internal point. What are design patterns, and what is object oriented design using unified modeling language. So this is an important open source or source development that could be covered later on. And what are the design principles? These are all the things that you have to cover in the this of chapter number 7, that is same in the same module. Okay, so context model, all these things, interaction, structure model we have come across. So behavior models, as I said. So as I said today, immediately after the class, I'm going to WhatsApp this copy of the PDF. Maybe the size was big, that's why I have not forwarded. I reduced the size of the PDF and I'll forward it today, so that you find it easy with respect to the topics that is being given in the syllabus. Okay, so model driven architecture. So you have MDA transformations in this topic to be discussed, and multiple platform specific models. Okay. So for that, just have a display the diagram of what is model driven engineering. Theoretically, you have to go through the classification of it and what is the MDA transformations and multiple platform specific model. So So for an examination point of view, maybe this topic I'll cover it later. So what I'll do, I'll switch over to the next chapter number 7, this topic. So I'll explain this topic maybe in next Wednesday, in my last session before prior to the second IA. So because I need to cover up these topics, okay. So let me go to the this topic. So model driven engineering, I say once again, I'll repeat it on next week, Wednesday. So because I don't consider more important for examination or internal point of view, and moreover, it is a theoretically at somewhat higher level. So we'll go to the design and implementation. So in this one, we'll first cover the design principles. Okay, design principles. What are design principles? Okay. So let me go to the what is design and implementation. It is a big topic, design and implementation. So basic concepts we have to understand what are the meaning of a patterns here, what are patterns and how do we design a patterns over here. So main objective of this chapter is to introduce the object-oriented software design. In fact, object-oriented uh, software. Okay, we are here right now. So here we need to understand the most important activities in general and object-oriented design process. We have to get an idea of design patterns and how these, what are patterns first you need to understand, and how these are a way of reusing the design knowledge and experience. We have to understand that. So first, object-oriented design using UML. What is Unified Modeling Language? You know it. What is the design patterns? You know it. So before I go to the topic object-oriented design using Unified Modeling Language, so let me have some theoretical background. What is design and implementation? What is design and implementation? We have few of the vocabularies that you have to uh, understand. What is build or buy? See, one of the example you can focus over here. If you want to implement medical record systems, you can buy a package that is already used in hospitals. For example, if it is a new thing, new applications that you are going to develop, but you have already that implemented part of it that is being available in as a domain. So if you want to implement a medical record systems, so you have a package that is already used in the hospitals. It can be cheaper and faster to use it. The thing is that the already existing system could be hired and that could be modified rather than, right, rather than developing a systems in a conventional programming language. So what is object oriented design process? In the case of object oriented design process, we have many concepts. So that is we have a concept of class, objects, what are attributes, so associations, class diagrams, all those things. There are many process stages. In fact, this is not part of the syllabus. I'm just going to understand what is object oriented design using UML. So here see, define the context and models of the system, design the system architecture, identify the principal system objects, develop design models, specify the object. And these are all the common activities in the process that might include during the process stages. So same thing he has explained what is context. What are context and interaction models? So interaction is a dynamic model that shows how the system interacts. What is context model? Same thing repetitive as a system we have represented over here. So in the case of use case diagram to represent the interaction. So use case description means what? Once you write a use case diagram, first you should have a description of the use case that is being represented. Architectural design, high level. So let me go to the main topic here. See, let me go to the topic today, first topic. Okay. See, all these things are being needed. I'll tell you when exactly you need to cover up with this weather station, state diagram and all. So object oriented design using UML. All of you just concentrate. So object oriented. So object oriented design using ML. So in this one, first topic that you are going to cover up is what is system context and interaction. So system context and interaction, all of you have studied this in the previous unit, that is what is context model and what is interaction model. The system context and interaction. What is system context? It is one of the first stage in any software design process. So that is going to develop an understanding of the relationship between the software. Okay. So it really helps in designing how to provide the required system functionality and how the structure of the systems can be communicated with this environment. In simple words, system context and interaction model represents the complementary view of the relationship between the system and environment. So usually the system context model is a structural model. Usually it is being used to demonstrate the other systems. Whereas if I say interaction model, as I said, interaction model is a dynamic model that it shows how the system interacts with its environment. Okay. So you use use case diagram and interaction model for it. So this diagram represents the system context for the weather station. An important point of view, represent the context model for a weather forecasting system. This is a context model for a weather forecasting system. Similarly, you have a use case diagram for a weather forecasting, weather station use cases. Identify the weather station using use cases. We use a different use cases over here. So as I said, before you start with the use case, you should have a demonstration of the what all the use case that is being used, that are being used. So this table represents the use case description report for a weather forecasting system. And we have different high level architecture also. See, one thing you could identify in this topic, so object-oriented design using UML. So all starts with the context, then interaction, then the structured, then the behavior. That is topic number 7.1 from the book. So you start with the context, then you have a structured, then you have a object class identifications. What is object class identification? So object class identifications is nothing but identifying the objects with respect to the attributes and its behavior. So object class identification, see what is object class? Identifying the object classes. Okay. So here are the diagram. Yes, here is the diagram. So what does the weather station object classes consist of? So this total diagram represents the weather station objects. If it is a weather station objects, this is an attribute of it, and these are all the behavior. Again, the name of an object or the class, attributes, and the operations of it. Clear? So design models. In design models, we have two types of models, structural and dynamic. Again, in design models, we use some sort of sequence diagrams to represent the process of a design, and also the state diagrams. The state diagrams. Okay. So I'll just show once again what are the design models. See, design models ultimately consists of sequence diagram and some sort of state diagram. The state diagram represents again for the weather station state diagram. See, everywhere the state diagrams and interaction diagrams are all common. Thing is that the scenarios are different. Scenarios in the sense, in some case they use insulin pump. In some case they use weather forecasting system or MSC PMS systems. That is also one of the system wherein we can represent in terms of the state or the interaction diagram. Okay, today as of now let me stop. So, and for internal point of view, what I more stress is the topics are not so easy. They are quite lengthier. I understand that many people have a lot of confusion. So how to cover up the topics and how to go through all the topics, it is not so easy. It is a, though it is a theory, it is a conceptual subject. I once again stress, those who are hearing to my class, it is not so easy subject that you understand so easily. It is a theoretically, but it is a conceptually. If you follow the concepts that I have stressed it, right? For example, today at the end, just I have told you what are design principles. In that, I just started the topic called object oriented design using UML. It covers all the topics of this context, interaction, structured behavior. Till here it consists. That is representation of a context by using a context diagram or a system diagram, representing the interactions by using a sequence and the use case diagram. Structural model, you use a class diagrams to represent it, and behavioral model, that is an event and state diagram. So all these topics are being covered over here in one way or another way by using different examples. Somewhere else here we have using a behavioral models by using micro one. Here we have used some of the models to represent using a weather forecasting system, weather stations, as such, nothing else. Thing is that depends upon the question, how do you get the question, right? So I will still elaborate this maybe in the next session. So maybe I'd like to go with the examination point of view, not fully covering of the syllabus with respect to the theory. Okay. So those who have not given the attendance in the chat session, I request them to give the attendance in the chat session. And moreover, we left with simply the concept design patterns, implementation issues. So I really find it that you people find it difficult online to understand this concept, but you no need to worry about it. So today, immediately after the class, I'll forward one of the PDF file that is directly Somaraville book, which is as per the this syllabus copy you have. You maybe you can refer it again if you have a confusion. You can briefly study, that is what are the concepts that comes in under this topic. For example, in the case of object oriented using UML, it is a very big topic that covers many subtopics. So in that, you just focus on what are the state diagrams, structure, class diagrams, the interaction models with respect to the weather stations as such. Okay. And you may refer the previous question papers and specifically the question bank that what I have forwarded. Okay.